Hey everybody, and welcome to a second video in the App from Scratch series on building an Android app with Kotlin. In this video, we're going to talk about pulling a JSON file from Amazon's S3 and using Retrofit to make that web services call. We'll then parse that data and show it in the recycler view that we created in a previous video. This video was taken from a live stream, so I hope you enjoy this long format video. Make sure you subscribe to get notified of videos on iOS, Android, and game development. So let's get started. And we'll get started. So I want to show you and introduce you or reintroduce you to a couple of libraries. We'll talk about databases using ObjectBox. We'll talk about Retrofit to call web services. Talk a little bit about JSON and pulling JSON into our application. And then finally, we'll be using Event Bus to kind of let all the objects in our Android application know about certain events that happen. First thing we're going to do actually is talk about web services. So I mentioned a couple different services and solutions for doing this yourselves, such as Express which is a JavaScript web server that we can spin up and make basic requests to, and we can serve up anything we want, including JSON, JavaScript, object notation. But what I'm going to do today is actually show you S3. And I like S3 for a number of reasons, because one, it's mainly used for storage. So you can store large files, you can store files that get accessed very quickly, where you might not want to run that through a web server because the web server has to actually take that request, process it, go look up the file, use the disk I/O to read the file, serve it up. And so if you can kind of offload files, again, that are highly accessed, if they're large files that you might not want to put on a web server, and again, you want something that's a little bit more robust than just a regular old web server, then S3 is a great solution. There's other solutions out there that are for storage, but yeah. All right, so S3, you can get an AWS account. Go to aws.amazon.com. They have a free tier for the first year, so all the stuff will be free for a year, and yeah, as long as you don't go over the free tier kind of threshold that they have, which is very generous, then all this should be free. I'm going to go ahead and create a bucket for this. You can see I have a couple builds in here, including Elastic Beanstalk, etc. So we're going to have all public access because we want to be able to allow our JSON file that we're going to serve up into this application be, well, publicly accessible, mainly to our app. And now if you wanted to protect it using like a password or something, it certainly has the capabilities of doing that, and then you can pass that using Retrofit to S3. And sometimes there's even S3 clients that you can get that just work with this, including upload and for storage if you're storing like profile images or whatever. So for this bucket, it has to be a unique name. I'm just going to call it something that I know is pretty unique, which is the Electronic Armory, and then BSU, of course. And that is going to show up in the URL that we're going to access. So make it something pretty, something memorable, and something that if somebody looks at that, it's not either inappropriate or just whatever, right? So the region is where these files actually get stored. So US East, well, it's in Ohio. We also have one in the great city of Portland somewhere. Let's see, where's Portland? Well, it's in Oregon. I'm not sure if it's in Portland, but somewhere in Oregon, which is a pretty big state, so who knows exactly where it is. But that's pretty close to us, so we'll pick that one. There's also, obviously, Northern California. Not really sure where that is, etc. exactly. But just pick the one that's closest because that will have the lowest latency. It's not a huge difference whether you choose Northern California or Oregon. Some of them have different features, though, depending upon the data center that you choose, but we're not going to get too much into that today. And yeah, so a couple other objects in here. We're just going to disable all that and create the bucket. All right, so we have a couple of other buckets in here, as I mentioned, but this is our bucket. You can see the access currently is not public for some reason. But we can change that. We can go through the properties. We can go through the permissions. You can see all the different kind of features that we get with S3 that we won't go through today. But I'm just going to say access control, and we're just going to make sure this is public. I can make this public on a per file basis, so I'll just do that instead. All right, so go back to overview. We're going to upload a file here, but I don't have the file just yet, so we're going to go ahead and create it. And if you remember, we're doing our to-do application. Because this is a list of to-dos that we have saved up on a server, obviously this is going to be static. I'm going to start this off with an array. And so we denote in JSON array with square brackets. And I'm going to give us some space in here. I'm going to tab into this and we're going to start giving this array multiple objects, multiple to-dos. So each object is denoted by a curly brace. So I'm going to give it a couple curly braces, or objects, I should say, denoted by curly braces. And then, of course, with JSON, we don't give the last curly brace a comma, but everyone else we do to separate the objects out. I'll probably end up deleting these anyway, but because I'm going to copy and paste these in here, but we'll keep them in there for now. And tabs are not necessary, but they're good for human readability, so make sure that we have them in there. But usually when the server will serve up JSON, it's all on one line. There's no white space. Saves a few bytes per request, and then when you have millions or hundreds of millions of requests, it will save you terabytes of data just with a couple of white spaces removed. All right, so let's go back to our Android application here. And if you remember, under our to-do model somewhere, totally forget where it is now, but that's okay. We're just going to jump over to to-do item using that navigation that I taught. All right, so we have this to-do item. So we have the title, we have the description, we have the due date, and we have the top priority. One thing I forgot last time was to put in an is done. So let's put this under here and just put a variable is done, and this is going to be a Boolean value. Should we use our commas to separate our data values out here, or variables? All right, so we have these three. I'm actually just going to copy these in here because I want to almost match these up with our JSON. So what's stored locally on the device will be stored on the server. Now the server might have additional information like date created, date modified, etc., right? We're not going to worry too much about that. But again, the server might hold additional metadata that we might not have here. All right, I'm going to format this a little bit better, so bear with me. So the title here, we're just going to do, well, let's give these some actual names. We'll try to be creative tonight. So to-do item for this one is, let's say this is a grocery list. So let's say, if I can spell tomatoes, and maybe we don't have a description on this. Make sure we put our commas at the end. Just getting rid of that far because we don't use that in JSON notation. And because is done is a Boolean, we don't need to wrap this in in quotes. Now the to-do due date. Now this, it needs to be a basic type, and there's no type in JSON that says it's a date. So we can either do it as a string, or we can do it as like a float, or let's say a long integer. So we can do something like the number of milliseconds since what, 1970 something, of course, something like that, right? Maybe not, it doesn't have that many characters in it. So we can do something like that and then convert it from the epoch time in milliseconds to an actual date. So that's one option. That's a pretty popular option. Another one is to do some kind of, let's put in, let's see, what's today's date, the 28th, something like this, maybe format it a little bit. Maybe you have a time. We'll put it in 24-hour clock here. Something like that. And then sometimes you'll even have time zones, etc. But then what you have to do is do the date formatter to match up. Okay, the first one is going to be a 4-digit year, then a hyphen, then a 2-digit month, etc. So this one's a little bit more complicated. I'm not going to actually parse this out today, but again, those are the two options that we might have as a response from our server back to our Android application. All right, so then the to-do priority, that one was just an integer. Let's give it a random number of 5. All right, so we're going to just have these basic types here. And I'm going to change the, obviously, the data here. I'll just go really quickly here. So maybe blueberries. You know, maybe there's no due date. That's another thing that you want to make sure you put the commas in. is when you're taking a response from a server, or you're the one that's responsible for generating that response, is trying to make your responses as consistent as possible. So try not to give back any null values if you can avoid it. So for the date, for example, we can give it an empty string. We can give it a string that says null, or uh, some kind of flag or some kind of value that basically says, there's no due date on this, right? But try not to just eliminate it altogether, because as I'm parsing this on my side, the client side, I want to make sure that those values are there and they're not null, because if they're null, then I have to do a null check. And I should probably be doing that anyway. But again, if the response is coming back is very inconsistent, then that causes problems for me as a client, as a consumer of your data. So if you're the one that's designing this, this is pretty important. Another thing that I hate to see with people who are not very good at designing APIs is if I'm expecting a bunch of to-dos to come back, but for whatever reason, maybe you only have one, or maybe it's a new user, so there's 0, that sometimes, let's say it's just one that comes back, the response, let's ignore everything past line 10 there, the response is just a single object. Passing back a single object as opposed to an array, again, on the client side, I have to figure out whether the object that's coming back is an array or it's a single type. And that's an extra check that I have to do. What you should do, in almost all cases, is just pass back either an empty array or an array of one object. Okay, because there's no reason why you can't pass me back an empty array or an array of one object. But if you're passing me back one object or 0 objects, then again, I have to do a whole lot of checks, and it's really annoying, and it's error prone, and what if I've always been handling it as an array, and then one day somebody deletes all their records, and yeah, there's no objects in the response, and the app crashes, and now that's out in the wild. Okay, so anyway, we got our data in here. I'm going to change this one more time. Let's say, I don't know, it's chips, right? Whatever. Just think, first thing off the top of my head. Oh, I also mentioned not to give back nulls, which is kind of what got me into that whole tirade in the first place, right? So give me back something. If it's an empty string, that's fine. That's a simple check. But again, if you're giving me back strings or integers or a whole different type of thing for these different values, then I just don't know what to think, and I have to handle that. And not only do I have to handle that as an iOS or as an Android developer, but on iOS, I also have to handle that. And on the web via JavaScript, I also have to handle that. And whatever else, if you're trying to hook up your toaster to this API, then whatever native language toasters speak, you have to hook up and do the same exact checks. So I like to kind of put all of the heavy lifting and the logic on the server, but if the server is kind of overburdened with a lot of these calculations, then sometimes it's okay to actually burden the UI or the client with a little bit of calculation. So, if you're calculating a whole bunch of things over and over again, it's much better to distribute that workload over amongst the clients. But again, that might be more data around client specific stuff. So whether you're displaying it into a list versus whatever, that might be more client specific, and you can put that workload on to the client to either alphabetize it or something similar, right? So anyway, that's enough about API design, unless you guys are more interested. I'm happy to keep going on, but I think we're pretty good here. Let's just kind of give this different priorities, maybe different due dates, just to make sure that we're getting different data that's coming in every time. Yeah, I'm not going to do anything with these dates. Maybe I'll just display them or something, but let's say this one is true. All right, so we want to save this out. I'm going to save this probably to my desktop for now, because I'm just going to upload it to the web, and I'm going to call this response. Yeah, so let me save. This is going to be a response. You can maybe I'll call it something like to-dos. If you're going to call an API and get like user information, sometimes that's just /users, /user, I should say. And oftentimes, if you're doing operations on the user, or that user is part of another group, you might do like /profile, like user and then group all of your APIs for your user endpoints under that user. So you might do like user slash profile, user slash cancel in order to cancel their account. So using the verbiage cancel to do an operation on the user, and then of course you would pass the user ID or whatever for that. So things like that. That's really where you want to design your APIs. I've seen some really bad, poorly designed APIs in my day, but let's see. Oh, okay, yeah. So it's complaining because I keep forgetting to put in my commas. No comma on the last part. A few minor details there. We have that all fixed up. Let's go back. Let's get rid of this window. Go back to our S3. Now we can just upload it. There's clients that you can use to upload files to S3 that's a little bit more robust than uploading files via the browser, but whatever. Okay, so that is 447 bytes. So hit next, and then what we're going to do, the user ID is the owner of this. You can actually create multiple accounts on AWS in order to have really fine permission control, but I only have one user on this particular account. And then make sure that our read options are good for this. I can turn off write, but it's really for the owner. So it doesn't really matter if I can write to it. Let's see. But I think that's all we need to do there. And all right, so I won't go too much into this, but if you have a file that's not going to be readily accessible, meaning like there's not going to be a whole lot of people that download it either every day, every week, etc., you can actually put it into something a little bit more long-term, such as Glacier. So this is more for archival purposes, where it's a cheaper storage fee. So they don't charge you as much per to basically to store it. But really the nice thing about S3, and I'm not sure exactly on the details, but they mostly just charge you based on the bandwidth. So they charge you to upload it and they charge you to download it. So yeah, storage is super simple. I know a lot of people that just use this as their main backup. All right, so yeah, just standard's fine for our case. Now Glacier is going to be a little bit slower in accessing, so don't just think you can get cheaper storage for free. When people do requests, they got to pull it up, and it, maybe it only takes a second or two, but it's not going to be as fast. Okay, so anyway. All right, so now we have this file. If we click on it, we can actually explore kind of the details of it. Really, the only thing that I care about is the endpoint. Now, I'm just making this up, and this is going to be a static file. So we just have a hard-coded static file. But if you had a web server, this will work exactly the same, minus the white space and formatting, of course. But we're going to copy the link as, and we do. So you can see, oh, no, that's XML. That's not JSON. So access denied. All right, I'm not sure why that is, but what we want to do is we can copy. Sometimes these don't work. It's usually either the permissions, which will double check that this is public. Oh, okay, yeah, so public access, everybody. Sorry, I was talking and doing this at the same time, so I thought this was being set. So read access to the object, account control stuff. So access to the object. Yes, we know, thank you. Yeah, here we go. Okay, sorry, I was just checking this. I'll show you what this looks like in a second. Copy the link address. I'm going to paste this in before I forget, and we're just going to paste it in some random spot for the meantime. All right, so that'll give us access to that file. I know it's ugly, but all right. So let's quickly dive into this. We're going to show Retrofit really quickly. All right, ladies and gentlemen, boys and girls. So Retrofit, just square.github.io and then /retrofit. So as I mentioned, it's a little bit more complicated than just a regular kind of library that we're going to be using, where you can just, some of these libraries, you just literally pass it a URL, and then inside of either a Lambda or a coroutine or something that you get the response, and then you can parse it from there. This takes a little bit of setup initially, but again, it's super dynamic. It'll handle almost everything that you need in order to do this. It'll even do like multi-part uploads, etc. So it's really, really powerful, but don't let the complexity of it scare you away. First thing that it's asking us to do is create an interface for our endpoint. So This is all in Java, but we're going to convert it over to Kotlin. This is an annotation. And then finally, what just the endpoint is, not even the server. So just the endpoint. So in this case, it's user/repos. But you can see that user is in curly braces because it is going to do a replacement on that user in order to give it the username for this. And we pass that in calling a function called list_repos. And then in the path, inside the path, which is, again, this part of the path endpoint, there is a keyword called user, which corresponds to this. And what value do you want to place in that? And it's just going to get the username. So this is a way of calling users slash, say electronic armory slash repos. And then that would go and grab all of my GitHub repositories up on there. So this is just setting up the endpoint. It's telling it what kind of method it is. It's giving us a little bit of string interpolation that we can kind of construct a endpoint with. Of course, you can do parameters, query parameters, all sorts of fun things with this as well. The next thing we want to do is set up a retrofit object that is basically going to be the object that carries out the request and any additional retries, or if you want to put it interceptors for adding your own headers, or if the call fails, you can actually have that come back to another object called an interceptor and handle it that way. Maybe you want to retry 3 times, etc. So this is the object that's going to take care of that. And you pass in the base URL for the server, in this case api.github.com. And we just use the builder methodology in Java. Of course, we're going to convert this over to Kotlin. And then finally, we create that after we created the builder. So we create the builder, that's kind of the plans of it. And we hand it over to the create object, and that'll give us the service. And then on the service, now we can call that endpoint, and we give it the username, in this case, Octocat. And what it's doing is, of course, this is Java, is it's expecting a return. And all returns come back as a call method. And inside that call, what we're expecting to get back is a list of repo objects. Now, this particular example code doesn't give us the repo objects, but the repo object is just going to be a mapping of the mapping of the object that comes back from JSON and maps it to your Kotlin data class files. So hopefully that makes sense. All right, so basically what we can do is we can copy these into the respective files if we want to. I actually already have some notes on this, so I'm going to get rid of this. But again, you can kind of just use this as a base for this. So I am going to create a new service, and I'm just going to dump it right into the main package here. It's going to be a Kotlin file. Of course, it's going to be a class, but actually it's going to be an interface. If you remember, the interfaces are going to be, well, basically the interface to our API. So let's start off with an interface. We're going to call it something really complex like to-do interface. To-do interface. I think I spelled that right. Okay, going to add that to the Git repository that I'll post at the end of this. All right, so in our interface, we're going to have that get API stuff that we have. We have a whole bunch of other ones like post, right? But this isn't going to work right out of the box. So let me just type this in just to give you the idea so we won't forget what we're talking about. And of course, that S3 bucket was just /todos.json. So pretty simple. And then we have that function. So in Kotlin, we just have function, and then we can name this one whatever we want to. So whatever makes sense in Kotlin, we can just say to-dos or current to-dos if you want to be a little bit more explicit. And what parameters does it take? Maybe this is where you want to pass in the user, get the to-dos of the user. You might pass in some other query parameters or other things for authentication, et cetera, et cetera. But this one's just going to be a simple to-do. And the return value, so again, Kotlin, we put this at the end instead of Java at the beginning. So this looks a little bit different from the website we just showed, but the return is always going to be a call. And then this is templated. So what kind of call is this going to come back as? And this is going to be our to-do item. So this is really nice because we matched up the name in JSON. Go back to our JSON example. We matched up these names, these keys, to the keys within the data class itself, right? So to do title, to do description, etc. However, sometimes you are the one that's making the back end, but more often than not, you're not the one that controls the back end. And instead of the camel case here, sometimes you'll do like underscores, something like this for your JSON. And it doesn't really matter, but this makes it nice because we can just do mapping automatically. If the names don't match up, you can do a serializable name and match up what's coming into the JSON to your Kotlin object. So, okay, so we haven't changed this. We don't need to update that again. But yeah, the object that comes back is still going to be wrapped in a retrofit call. And then inside that call, we expect to have a to-do item. All right, so I actually forgot the main step, which I kind of meant to do, but it's okay that we forgot, is somewhere down here. All right, so we just have to make sure that we copy this line of code so that we add it as a dependency, just like normal. So I'll go through this really quickly. Oops, wrong one. No, that's right. Sorry. It's just down here. And I don't know, you can organize this as well as you can, but it gets kind of messy after a while. All right, so this one says insert latest version. And so the way that I do that is I will go to the actual GitHub repository. Yeah, sometimes you got to hunt around different projects, but on Retrofit, they have a nice little Octocat symbol. All right, so now I'm looking at the Git repository. I am going to go up to releases, which is down here. So make sure you're on code first and then releases. There's 52 releases. And you can see on March 25th, let's see. Yeah, there's version 2.8.1. Sometimes it's okay to use the latest and greatest and then paste that in. Make sure you don't kill the last bracket there. All right, so if you're unfamiliar with this process, just make it look like all the other things in here. You can do variable replacement, like this $Kotlin version is defined in a different file, so we can click on that. Well, it's defined here. It doesn't let me jump to it for some reason, but Kotlin version 1.3.72. But yeah, so again, we can use variables within Gradle. All right, so then we're just going to sync it. So go up to the top right-hand corner, sync it, and we should be done with that. Now, once that is synchronized and done building, it'll download the package. If you have it in cache, it doesn't need to download that version. Alrighty, so once we have Retrofit as part of a dependency in our project, this should work. So we're just going to kind of click over here. And so now it will pop up. So Alt return will give us the import, and it's going to ask us for the call method as well. Alt enter. And so there's a couple ones on here. So make sure you do the Retrofit version. You can do OK HTTP, which is what Retrofit uses kind of under the hood. But let's be specific about it and use the Retrofit one. All right, so the next thing we need to do is set up the service. Go up to my package, right click, Kotlin object, and this one's just going to be called web services. Call this whatever you want to. Okay, add that to our Git repository. I'll go through this one really quickly. So reminding you what this looks like on the Retrofit side. Okay, so now we're just going to set up the service as I mentioned. I think I've talked about these before. I'm going to create a service on this one, create a private variable. Let's do a private variable called service. And this one's going to be based on that interface. All right, so this one, what I'm actually going to do, because this is an object, init. So we're going to create that retrofit object, that builder, and then go through the builder process. So I could paste that in, but let's just do it by hand. Retrofit.builder. It's a function. And then we're going to put it, oops. It's getting a little bit of dot base URL. So that base URL is that Amazon link, which I put here. Hopefully this doesn't mess it up too much. All right, so I don't need, these are all the parameters. We could put those into the interface. Didn't expect it to be that long. All right, so those are query parameters. We can actually put those in. I'll show you how to do that. Okay, I think Retrofit complains if you don't put in the trailing forward slash, so I'll keep it in there. It'll let me know if I'm not supposed to put that trailing in there. I always forget. All right, so for this one, we can put in the query parameters if we want to. However, let's see. I think I'm just going to paste those in for the sake of time. Don't do this, but, oh, I pasted that in twice. But yeah, you can set up like the response content disposition query key is equal to attachment. So I'm not going to do that because well, maybe there's only two, but if we have time at the end, which we never do, I will do that. All right, so we have the base parameter. That's just going to be /todos.json. And then finally, what we want to do is, what we could do is just do a build on this and then initialize that service that we have at the top here and initialize it to the retrofit.create. And it's going to ask us for the class or the interface that it wants to build this off of. And this is going to be our to-do interface. Okay, so we can't just pass in the class, so like in Kotlin, we do class.java. All right, so this service now is what will allow us to make these calls. And then we have to actually make sure that we have an interface to the endpoint, but what we need is a function to call that retrofit version of that endpoint. So as part of this web services class, I am going to create a function. This is because it's an object and not a class. This is going to be a singleton that we can just call this on. So I'm just going to say to-dos. This is a function called to-dos. And as part of the what do you call this? Parameter, excuse me. Part of the parameters you can pass in, again, the username, or you can get that as part of the web services, etc. So you might have to architect this a little bit differently if you're trying something a little bit more complex, but we might not have a return value on this because this is going to be asynchronous. So you might want to put in a callback for this. Let's actually do that real quick. So the callback on this, we'll just call it callback. That's the variable name. And then of type, and Retrofit has a callback type. So callback, here it is. And then it's a templated part here. So this callback will just be on, it'll pass me back a to-do item. All right, so again, this function is going to call that endpoint that we just set up. So we want to save that into a variable called call. This is the call or the request that we're making. And then this is the service object to actually make the call, dot. And then again, if you remember, we have that interface on there, and that interface is current to-dos. So it's a little, again, it's a little bit confusing how to all set this up and then kind of how to call the endpoints. But again, the endpoint is defined via the interface. You create the retrofit service using that interface, and retrofit will use that interface to make its own functions and do the own implementation for those functions within the interface. And then that allows you to call those functions that are implemented on the service that we just created. So again, hopefully that makes sense. And then on the call, on that call object, we can call enqueue, and enqueue, I can spell it right, N-Q-E-U-E. There we go. And queue, we'll put it into the retrofit call, or into its queue, hence the name. And you can have priorities, so maybe some calls are more important than other calls, etc. And you can prioritize them, etc. like that. But anyway, we won't get into that. So we make the call, and that will actually go back, and that will make the request, pull in the data, not parse it yet, still missing that. And then when it's done, it will call me back on the callback that you pass in. Okay, so who's ever making this call, whatever object makes in this call, it's going to give me a callback. We're going to use that as our lambda, show what that looks like in a second. and then this will pass it back. All right, so hopefully this is not too confusing, but again, this is pretty much all we have to set up. The only other thing is we have a bunch of, let's see if we can find it. Yeah, okay. I was typing in converters, but this is the section of Retrofit that I was interested in. So in case you don't want JSON coming from your server, or your server's not passing you JSON, maybe it's old and somebody doesn't design APIs well and they want to convert, send you back XML for some reason, either via SOAP, which I don't know why that's still around, but we have a bunch of different converters. So JSON is the Google version of JSON. We have Jackson, we have Simple XML. So these are different converters that will take a different kind of intermediary language, such as JSON or XML, and convert them into a Kotlin object. Or in this case, it's technically a Java object or a POJO, but of course we're using Kotlin, so we have Kotlin. Anyway, what I need is to add this as a dependency to my application so that we can use the JSON converter, and they'll show you how to use it here. So actually, I'm just going to copy that right here. And we build that as part of our, when we're building the service. Now you can see that this is red because we didn't add the dependency. Not sure why the highlighting is not working. Go back to our Gradle file. Implementation, and add the JSON converter. Now on this, we can actually make this call to go grab our data from the web service, and the web service is the retrofit library is going to parse it for us. So on the return for this, we'll have all of our to-do objects. All right, so I need to grab the version of the JSON library, and we do the same thing. We go to releases, and we'll just grab 286. So that's how I know when I go back to my Gradle file what version to put in here. So what I say, 2.86, 2.8.6. Failed to resolve. Okay, so maybe that did not work. Let's go back a couple versions. Just match it up with the retrofit one. All right, so yep, everything looks being built great. I'm going to go up to our build menu, which is off screen for some reason, and just do a make project. We'll resolve that in a second. Okay, yeah, so this never did resolve after putting all that stuff. No argument, no type arguments expected for interface call. Oh, okay, perfect. So as I mentioned, I imported the wrong library. So I imported the right library for this one. This is what I was talking about with using Retrofit versus OK HTTP. For some reason, it included the wrong call package. So that's why it's complaining about this argument here. So, all right, I don't know. We can just do this manually. I'm not sure why that's not working. This is the one we want, so hopefully you know what you need. Sometimes the autocomplete in Android Studio is not the best, so I sometimes rely on it too much, but this is the one we want. We want the call from the Retrofit 2 library, not the call from the HTTP3, OK HTTP3 library. Okay, so that's the one we want. Sometimes it auto imports, sometimes it doesn't. All right, so now we're good to go for there. Yeah, if you get weird errors, just make sure you check your imports. I guess that's the only thing I can really say. I'm going to delete that. We don't need that anymore. All right, so all that time we set up just to call some data. Let's call the data. You can do it anywhere in the application because we set up the web services as an object. In our main activity, we can do this, and that's fine. But let's say you want to do this slightly earlier than the onCreate in your main activity, because at this point your application's almost ready to go. Whereas it could have been downloading the data in the background this whole time, building the interface, and then by the time it's built the interface, launched your activity, shown your activity, inflated the XML, all that fun stuff that we've talked about a long time. We have the app, which overrides the application class, and then it has its own onCreate. So I'm actually going to put the call here. We know this is working, which is why we already have it in there. Web services, to-dos, and part of these to-dos, what we can do is, sorry, this is our callback. Let me show you this. Okay, so this callback is expecting a parameter that we can give as a callback. Sometimes we can just give it as a lambda. I don't have it set up as a lambda here, but we can give a callback for this. But what I actually want to do is this will parse the data and then give it back to us. But this is the inappropriate place because we have a to-do manager. But we don't have any way of storing the JSON that we have back. So I'm going to create a function called, let's say, update to-dos. This is just going to take no parameters. So this is going to be the one that's responsible for calling the web services .todos. Okay, we'll fill that in a second. Okay, got to go back to the app. And web services to do. Now we're going to delete that and call the to-do manager dot update to-dos. So this call right here will go and fetch as soon as possible, or we can even make it above the log statement there to make it a millisecond sooner. But basically, as fast and soon as we can, we're going to go ahead and try to download that JSON. That way, when our interface loads, hopefully the JSON is loaded, but that's not a guarantee. So we want to make sure that the data has been downloaded, parsed, loaded before we expect it to be there, because it could not be. I mean, we're trying to do this as soon as possible, but it doesn't guarantee anything. Okay, let me go ahead and build this, just to make sure we don't have any errors. I think we do. Type mismatch in the date. Add to do. What did we change that to? Oh, we changed that to a string. Okay. And type inferred type integer. The date was expected. Okay, so required Boolean found string. Oh, is done. Okay, so I added a parameter. That's why. Okay, I was confused on why that wasn't all of a sudden working. So is done is true. Now in Kotlin, this is really nice because we can actually name our parameters. So we can name this is done, and we can switch these around if we want to, or just be explicit. And this one is the priority, so I can type in priority, and that's going to equal enter integer. So we can have name parameters if we want to. It's kind of nice just because when you have like 4 parameters, it's hard to remember which one is which. And I was reading to do as due date for some reason. Okay, let's build this again. We did change that our data object, so I guess a couple more errors in here probably. All right, so no value passed for the to-do date. So put that in, to-do date equals date, and that's going to be our string. Oh, okay, so this one, sorry, I'm getting my types wrong. Sometimes it's a string, sometimes it's a data object. That's just my bad planning on that part. All right, so let's do one more build. Okay, so we added that parameter to our data class, so this is all off now. That should be fixed now. All right, so that's we imported the dependency, but we didn't import the package. There we go. Now we should be good. All right. Sometimes it's not about what you know, but how to solve these problems. All right, so no value passed for parameter callback. So we want to put in our callback here so that we can handle the actual call. And then when it's done getting the data, that we actually can retrieve that. So for this one, we get a couple of different callbacks here. Let's split this up so it's a little bit more clear. So I'm going to have a callback object, so I'm just going to call it callback. Then we're going to pass into that parameter, or that function as a parameter. And we're going to set this equal to an object, and that object is going to be of type, if I can type, of type callback. Make sure we're getting the right callback. So callback retrofit 2. There it is. So when I hit that one, it'll auto import the library from above. And this is going to be of type to do item. Again, this will all go in the repository. So if you're trying to follow along, I'm going to go kind of quickly here. So we're creating an object callback that we can then pass in as a callback. So I'm going to just type that in. We're not done yet with this callback because what we're doing is we're overriding this callback to allow us to have the different I was going to say callbacks, but the different functions, whether it's a successful response or it's an error response. So that's what we're going to handle here. So within this, we give it a body. And I think we can kind of do Control O, and this will bring up our overrides menu because I can never remember the function, the signatures for the functions that I need. So I just do Control O within the body of this, and it'll give me the functions that I can override. So on failure and on response. So again, Control O will bring up this window, and we can hit enter, and voila, it kind of writes all that code for me, which is why I lean sometimes too heavily on the IDE. If you give me just a text editor, no way could I do this from memory. But yeah, it's little tricks that will help you go a lot faster. All right, so on failure, I don't know. We just log this out for right now. Don't do this because that's bad form. We want to handle our errors, but we can do something happened, and then we can even just type in what the error is. Let's see. It's a toString, something like that. It'll wrap it in curly braces for the string interpolation. I'll just leave it at that. Hopefully there's no errors. If there is, I'm going to put breakpoint here. Maybe the parameter was called incorrectly. All right, so then on response for this is going to be the actual code that comes back, or the JSON, I should say. So this is passed in as a response. Okay. In call, we can get the original request, just in case maybe we have multiple requests out and they're requesting different pieces of data. So this callback and this call object will let us know what the original request is, and we can base that on, again, if it's like for different users, if we're grabbing images, whatever it is, we can query this call object to see what the original request was, and that might influence our code here. As I mentioned, this is a response object that gets passed in. Our response object, we can query a couple different things. We can get the body if the data is being passed in the body of the response. We can get the code. The code is going to be the status code that is it a 400? Is it a 404? Is it a 200? If it's an error, we can get the error body. Any headers, accept headers, authentication headers, all that fun stuff. We get the raw response if we want it. So I'm just going to make sure that the response is successful. Usually when we're in this, it should be successful. Even a 404 is considered successful. So believe it or not, that's successful. We'll get this callback on line 28, but is successful. This function is going to denote that it's a 200 something. So 404 will actually not go into this. So it is successful. Let's put this into I was going to put this into an if, but actually I can put this into a let. So if it's successful, what I can do is get the body. So we're going to log D for debug and just put in the response body. Okay, so we call response and then body. Let's see what our errors are. Okay, yeah, it's just expecting a string when we have a to-do item. So I'm going to just do the to-do title. Let's see. So if I hover over this, it says required string, but it found a to-do item that's a nullable. So I'm going to unwrap that and do to-do title. Oh, shoot. I totally botched this whole thing up. This is an array of to-do items, not a to-do. So this will fail. So now I got to refactor half of this stuff to give me a list of to-dos. So sorry about that. Let's fix this really quickly. Can't believe I just totally botched that. Just wrap this in an if statement so we don't confuse anybody, including myself. Let's see, use of getter method instead of the property syntax. All right, so now we have the error. So I refactored all that to accept a list. Now our callback is, or our to-dos is giving us an error because it's expecting a single object instead of a list. So I'm going to click into that, command click into that, and of course change it here as well. And should have to change it in the interface for this guy. Yeah, I totally messed that up a bunch of times, didn't I? All right, guys. All right, so now we're making the call to our made-up JSON, static JSON object. And maybe in the future I can set up a server if you guys are interested, but we don't really care about that at the moment. And let us do a quick build. Okay, so the build is good. I'm going to put breakpoints all over the place so you can see how this works and what order. This is an interface, so code shouldn't actually get executed in the interface. I'm going to put a breakpoint in our overridden application class. So you'll see that this should get hit first. It'll go into our update to-dos. And then in our callback that we just wrote, it will define the callback here as an object, and then pass in that callback into our web services object that we just defined, and use that here, but the callback won't actually get called until retrofit is done, and then it'll call our callback and then pass in the data. So I'm going to put breakpoints all over the place. And I don't think we need any here. Now these are different than the ones that we did last time on Tuesday. So these are our local version, and then we have a web version now via web services hitting that JSON endpoint. So now we have two pieces of data. So make sure you hit the bug for debug. Otherwise our breakpoints won't get hit. All right, so the first thing, as I mentioned, this gets called first on line 9. Our to-do manager is going to try to pull the JSON from web services, from the internet, download that, parse it as soon as it can, and then maybe it's done before our main activity is up on the screen. Maybe not. We're not going to rely on that fact. That's called a race condition. Which one gets there first, right? If we don't have data and the UI is created, our UI won't show data. If our data is there first and then the UI is created, then it will show data. And so, there's two different situations depending upon what's faster. So I'm going to hit the continue button. Should go into that function, update to-dos, define our callback. Oh, I didn't put a breakpoint in our success here. So just if it fails, I'm kind of expecting it to fail the first time around. But it's I'm going to step over that line of code. It's just defining our callback. And there we go. And then inside of our initialize for our web services, it's going to go ahead and create that service. Now it's created that service. It can call the to-do function. This is our callback that we just passed in from up the stack. And we can look at our stack in the lower left-hand corner and see that this function has been called by this function. And our update to-dos function was called by this function. So we can go kind of back up the stack, go down the stack, and see here, and we're going to hit continue, and nothing happens for a second or two, or more. I might have to make that callback static so it doesn't go out of scope. And wow, this is not working. It works. I don't know what it was. Apparently, according to Stack Overflow, I just need to delete the app and rerun it. Don't ask me why that works. Sometimes it just gets in a state and you got to delete everything and restart. Okay, so now we've got that working. Sometimes it's not your fault. All right, so code 403, forbidden. And you can see that it was trying to use this as the URL. So again, I was concerned about that. We can look at the response. There's the response here. We can hover over that. We can expand this. We can look at the raw response. We can look at the actual request that it used. So this guy here, this is the URL that it tried to use. The URL, I'm just going to go ahead and right click on that, copy the value. I'm going to paste this in my web browser. And voila, indeed, it had expired. So it says access denied. So I really did need to update that token. So my bucket, it has its own properties. So block public access. Let's go ahead and edit that. Save. Yes, confirm. Type confirm. Confirm. All right, so now the bucket, it doesn't block all, it allows all. So now we have per file permissions like I mentioned before. So if I click on this, access is still denied because we need to set the permission back. It was blocking us. Read object. Yes, we know everybody will be able to read it. Read object, yes. Okay, so that should be fine. We'll go back to our overview. There we go. Okay, so I should have taken the time just to do that in the first place. But now the nice thing is we don't need the security tokens. We can just grab that and go to our interface. Okay, so this should work. I have so, wow, this is what it looks like. I have so many emulators open right now. There we go. Okay, so this one's still errored out. JSON syntax exception. All right, so something's not matching up with our JSON, which is fine. We can step over this line of code, go to our logcat, see what actually it spit out. Search based on that BSU tag. Yeah, sometimes your two strings don't actually work that well. So we can look into the request and then get the body from here. Okay, so I'm going to use the Pixel 2 API level 29. Okay, so we're getting that socket exception again. So this is the old emulator. A lot of example ones. We're going to uninstall this just so we have a fresh. And I don't know what was causing that, but sometimes again, just deleting everything and restarting sometimes fixes it. So I'll see if that fixes on this emulator. As I like to say, it's not what you know, but sometimes how to fix the problems that you do have. All right, cool. So again, deleting it, reinstalling it, got rid of that socket exception. Anyway, JSON exception, perfect. That's fine. We're going to step over this just to print it out to logcat. Oh, okay. So here's another issue that I sometimes run into with running multiple emulators is I'm still on the old Nexus 5 Japanese one. And of course, I mentioned I was using the Pixel 2 API level 29, so that's why my log was not updated. All right, something happened null. So the request body came back as null for some reason, which is probably why I was having the JSON syntax exception. But, oh, okay, maybe it's the date. Could be the date, because if you remember, the date was actually a string type. So voila, that's why I said the number. The exception that I was getting was kind of helpful, but not really, because it was giving me a number format exception. Long story short, I just needed to convert it from a date object to a string just to get it to work. But you can see that on the response call here, we're getting that response 200, message OK. And then as part of the response body, if I step over this line of code and then go to our logcat, you can see that we now have an array of to-do items with their respective values. That comes from, if you remember way back in the stream, our made-up JSON file that we uploaded to S3. So in our application file, we were going to kick this off from our to-do manager. The to-do manager is going to manage all of our to-do items, whether that comes from web services, whether it comes from the user, emulator issues, and I should say S3 bucket issues that I should have taken care of before. All right, guys, so this is all working now. It's all architected the way that it should be. Anytime we want to update our to-dos, we call the to-do manager to update. We might have a save function that takes all the local to-dos that we've created on the Android device and then sends it up to the web service. Obviously, our web service is very basic because it's just a static file. But this is a nice way of pre-populating your app with data so that the user doesn't come into your application and see an empty list. So yeah, it's just a bunch of kind of hard-coded items here. But now that we have all of our to-dos in an array, we're just putting this out to string, right? And I haven't loaded it yet, but now it's an array. We can just actually just take that array and it's all of to-do items. And we can add it to our to-do list. So here's our to-do list. It's a mutable list. So we just say add or add all. Let's see, what's the best add? And just pass in, don't do this, do this a little bit better than I'm doing, but essentially we're passing in the body, which is an array of items. And I know that because the response body is a list of to-do items, that I can add it to my list of to-do items that it currently exists. But we still have that race condition where if the UI is ready before, it'll show the static list, and if it is not ready yet and we've already loaded this, then it'll load it and the UI will reflect the downloaded items. So we have a race condition here. So I don't know if this will be lucky enough to show all of this. So these are the items that we're getting from our JSON file. So you see tomatoes, blueberries, chips. Nowhere in here did I parse any JSON. I just said these JSON titles here, these keys, match up to my class that I have, my data class. And if they don't, you can always add a serializable name by doing something like this, at serializable name, or serialized name, I should say. Okay, so again, if this maybe had an underscore or an underbar, some people call it, this is the name that's coming from the JSON. But of course, it matches up exactly with the name that I've defined here, so it just works. But again, if this is coming from your server, then you can give it predefined names. So here's our tomatoes, here's our blueberries, here's our chips that we added to our to-do list. Again, this comes from the server. And again, if this is an application that a user is first downloading, you do not want to show them an empty list. You might want to show them actual to-dos and give them an idea of how the app works, right? So we're going to stop here for now and continue implementing Event Bus in the next video. That'll allow us to let different objects in our application know that an event has occurred, such as the addition or removal of a to-do item. Thank you so much for watching it this far into the video and into the series. Give it a like if this has helped you out. Subscribe so you get notified of additional videos in the series and others in iOS, Android, and game development. Thanks, and we'll see you next time.